Hey, hi. In this video, I will help you to understand what is start and end of DevOps roadmap for 2025. In this video, we will see what is the DevOps actually means, why the DevOps was been brought in into the IT organizations, what are all the principles of DevOps, what is the tools and technologies used in the DevOps, and eventually how it is helping the organization to give maximum output of the IT organizations, right? So that is what we're gonna see in this video, which will actually help you to understand what will be the roadmap for you as a DevOps engineers. Now let's go ahead and try to understand what is DevOps. Now DevOps is basically it is a culture and a set of practices that unifies software development are called as a development team, and IT operations are generally called as an operations team. Now, in early days, there were two teams who used to look at their own verticals of the work. One is the development team who is used to look at the development of their applications and purely focusing on business need of the application. Then the other side of the team, that is operations, who used to look at the fundamental operations of the business, or under the hood, they used to look at the infrastructure where the application is hosting. Now, when these work culture or when these units combines together, then only the IT organization will realize the value. But if these two teams works in their own console and they never care about collaborations, which will eventually lead to a lot of problems to the organization, and it will actually slow down their business deliveries. And that is a problem the DevOps is solving here. So how we are solving, basically, these two teams are now brought together as a unified unit, working towards making or delivering a single cause, right? And that is aims to deliver an applications at a faster rate, more reliably, and with a high quality. So that is basically is DevOps under the hood. Now we go step ahead and try to understand why this need came in picture for the organization when it was working fine, right? So look at the picture in the right hand side. So that is actually a team, but that has a lot of chaotics in it. When a team is running with a lot of chaotics basically, or a lot of problems within the team, definitely it cannot lead to deliver good applications which can enable the business to deliver more values, right? And that's the reason the challenges were identified before the DevOps were the slow software delivery, poor collaboration between the teams. As I said, there were development team, there were operations team, there were no collaboration between these two teams, which is actually need of for the business to deliver good values. And that's the reason it was causing a slow software delivery, lot of chaotics in the team. And then there were a lot of manual processes leading to error. Earlier, the managing the source code, there were a lot of manual process. Managing the operations, there were a lot of run books, lot of documents that has to be manually walked through to understand and operate the systems. Okay, that's where it is actually leading to a human errors, right? So that were the challenges earlier. Now when the new methodology is being discovered, that is DevOps, what are all the benefits that we cannot see right away, right? So as you see that when dev and ops are come together for a single cause to deliver more business value. Business value is a general meaning of the software delivery, right? So when you have a good software delivery at a right time with a right agility, right accuracy, that will actually fuel to a better business delivery. And that is only possible when dev and operations teams work together in a collaborations way, and work for a single cause, that is a better business delivery. So that's the reason it is a faster time to market. That is the first benefit that you realize for DevOps. Automations is basically, it's a blood of the DevOps, in the sense you do automation in the DevOps. And of course the better collaboration is basically the skeleton of the DevOps. Now with that said, let's go ahead and try to see the next, what is the core principles of DevOps. So as I said, the core principle here, so as I have discussed about why the DevOps came in picture, because there were a lot of the lot of teams are working in their own console. They were not caring about collaborations, and that was causing to the business delivery problems, right? And that's the reason the fundamental trigger point for having the DevOps is collaborations and communications. In the sense, bring a lot of collaborations, which is leading to a lot of communications between the team who is working for a single cause. And that is where the fundamental principle of the DevOps is talks about. Now, that is basically people problem. In the sense, when you achieve the collaborations and communications, what is the next technological problem, or the speed up the problem, right? Speed up the processes. That's where the automations comes in pictures. So automation is basically, it's a horizontal thing across the development and operations, that you can bring in and try to minimize the activities through the lot of coding ways. In the sense, instead of doing manual way, now you do it with the code. That is that is what that talks about automations. We look at the another one. So earlier days, the when the source code was been built, so that used to be, they used to do it with the manual approach of zipping the code, manually building it, right? And you don't have a version controls where you store the team's code in a centralized repository. So those are a lot of problems in there, right? So here what it does is, it tells that, for the source code or for your business application, you must use continuous integration and continuous delivery. So continuous integration is talks about where you continuously integrate your code so that all team can contribute to a single source of code. Okay. Delivery means, you use that same source code and try to deploy to the particular infrastructure, which will actually deliver the applications to the business. That is where basically it says CI/CD is nothing but, it's basically end-to-end automated the software delivery. It's a tool that can help you to end to end deliver the software. The next one is basically infrastructure as a code. This is this is again has bring in a lot of velocity to the infrastructure side. Earlier infrastructures were being spin up manually, like server build using manually, DB creations with manually, writing the DB configurations manually, server configurations manually, right? So that is a olden method of managing the infrastructure. Now you can build everything, you can deploy everything with using code. So we have brought a technology called infrastructure as a code. In the sense, you can purely write down the infrastructure in a declarative language, which will define how your infrastructure has to be. That is where it uses that methodology to run the infrastructure where your application is needed. The next one is, once the application is being hosted, now continuously have a monitoring, and even monitoring is being using the automations, lot of infrastructure as a code, and have a continuous feedback as well. And then the final is basically talking about testing and security. In the sense, you have your application, you do rigorous testing and check at the security angles. That is where the um, shift left principle is talking about. So basically, at a high level, these are all the core principles on which the DevOps methodology is standing. The next one is, we will look at now we will go a little bit of, one step ahead and look at the DevOps life cycles. So DevOps life cycle is, very, very simple that you need to understand. And this is the infinity symbol, that should be coming to in your mind when you say DevOps life cycle. Now, as you see, it looks like a infinity, but actually it means that, two teams are being merged. That is what this symbol means all about. Okay, it's not about infinity value. Now you see that there is there is the dev side, there is ops side. Now let's start from the plan basically, right? So if I can talk about the life cycle in a little bit of details. So now you have a business requirement. Now to deliver that business requirement, as the in terms of the IT, you have to plan it. In the sense, you have to plan that business requirement, like what is that we have to convert into an IT deliverable, like designing the solutions, designing, writing the maybe writing the algorithm, preparing the system design, and then converting that system design into a code. Okay, that is where the planning is comes in picture. Now you have a system design, that's where we call it as a plan at a layman term. Now once you have the plan, next stage is code. As you see here, if you follow my cursor, so you have the system design. That's where, in the sense, you got a plan. Now you're going to convert that into a code. Say that you are writing that code in a Python, Java, .NET, or any languages. So you're going to write that into a code. Now once you have a source code ready, you need to build it so that it can be deployed into some spaces, or locally, or maybe in the development environment, and you're going to do a build. That is where it talks about you build your source code, you code it. Now you're going to build it as a zip file where you can deploy and test it, right? So basically you are packaging your source code. That is what called is as a build. Once the build is completed, it will be deployed, and that's where you're gonna test that the functionality that you have coded, right? Once the test cases all are passed, that's where the release, the cycle begins in. So when the release cycle starts in, basically it's an activity that is actually oriented towards operations kind of activity, but this activity is still done by the, it could be done by a developer, or it could be more done by the an operations guy as well. So that is where it's basically merger of development and operations activity, right? That's where you see that the green part. So green part that you see is talking about more operations activity. So we have a release which is talking about releasing a features. To release a feature, you need to deploy to a particular, the environment, and that is what the deployment is talks about. Then the operate, once the your code has been deployed some on the some infrastructure, that has to be have an operations which will continuously check at the lifecycle management of the application, check if it is working fine, if it is available perfectly, is it scalable, is it performing as expected. That is where the operations comes in picture, and that operations is basically powered by a monitoring. So you need to have a monitoring system which can enable to deliver that kind of capability of monitoring, right? And once the monitoring is been done, let's say that you have find out that, hey, your application is responding with a very slow the response code, it is taking 10 seconds to response, and it is not scalable, sometimes it is going down. So these are all nothing but what, these are all problems of your application. Again, those problems you're going to give it at a feedback as in your backlog of the DevOps, and that is where again the plan cycle starts in. And this infinity, so you see that it came here now, from monitor it came to the plan again, then again it will again circle like this. It's basically infinity, in the sense it is continuously keep doing like that. And that is what exactly the DevOps life cycle is all about at a high level. Now we go to the one more important topic that you need to understand when you are stepping into a DevOps methodology or DevOps work world. So here let's see what are all the key tools. So now the key tools that is serving a particular purpose in the DevOps methodologies. First one, as we talk about in the principles, right? So we talked about in the principle we had a CI/CD. So to deliver the CI/CD, we need a set of tools. Here I have given an example of the tools which is very famous in the market or very famous in the IT organizations, but your organization can be using some other CI/CD tools. So here one is the GitLab, Jenkins is the one, and GitHub Actions. So GitHub Action is the latest tool that is booming up, and I recommend you to study GitHub Actions or GitLab as a CI/CD tool that you need to understand when you are entering into a DevOps world. And this is very easy to learn. And I have my channel been provided with a lot of videos, and I have a plan to deliver an independent, the learning tutorial on the GitHub, and that is coming out in a few days. So that is talks about the CI/CD tools. Now we go about the version control. So version control, that is basically, it's a centralized application where you can store your code in a basically version control. With a version control capability, lot of team members can contribute to a single cause, that is basically working on a single project. That is what version control is all about. That is, here is a Git, and Git is the only version control tool that is highly used for now. So I recommend you to learn the Git here. And then the configuration management. So configuration management is kind of basically this could be a SaaS application, or this could be the on-premises hosted or cloud hosted application which manages the configuration lifecycle of your identity of your the systems where your applications is been hosting. It could be server, it could be serverless, it could be database, it could be the Kubernetes, like that. So here is the Puppet, Ansible, and Ceph are the tools that you can use it for configuration management. Then the container. So container is basically another a technology where you are being allowed to host the container applications. So container applications is altogether, it's a big mainstream, and this is the primary choice for lot of organizations of lot of business types where they want to host their applications on the container. So here you need to understand what is Docker and what is a Kubernetes. So Kubernetes is basically container orchestration open source platform, right? And Docker is basically a runtime where actually it will convert your source code into a Docker image, and that with using the Docker image you can run it on a Kubernetes, run it on a Kubernetes cluster. And Kubernetes is a system which will orchestrate your container applications. That is what the container is all about, and you should be learning that. The next one is basically monitoring. So now we have seen across a lot of things. let's dig about the monitoring. So generally, Grafana and Prometheus. So as you see here, so these are all nothing but Grafana and Prometheus are the open source tools and technologies that you can basically learn on, which will enable you to monitor the your applications or your infrastructures. So that is where the Grafana and Prometheus comes in picture. The next one is cloud. So basically, cloud is, as you know, the cloud is basically where you get a all those hosting environment as pay as you go, like that. So major the cloud providers in the IT world is AWS, Azure, and of course GCP. So these are all the cloud that you need to understand, you if you want to come into a DevOps, especially in the cloud DevOps. Right. So now let's go ahead and try to understand one more thing. So right now we have learned about tools. Now let's learn about technology. That's basically languages that actually powers the DevOps. Now you got the Git as a source code repository. You got CI/CD as you are the code build and code deploy. Right now, while do that, you need certain languages that actually powers the DevOps activities. First one is scripting. So scripting is basically, as I say, it is actually, it's kind of a wheel of your DevOps, I would say. So when you have a proper scripting skills, then only you can excel in the DevOps world. So first one, I recommend you to understand the Linux system. When you understand the Linux system, I'm sure that you understand the bash scripting. So you need to know the bash scripting for working in the Linux environments. Especially if you are working in the Kubernetes environment, you need to have a Linux proper knowledge. So learn, the bash, which is basically learning, it's equivalent to learning the Linux environment. Then there comes the PowerShell. PowerShell is, basically it's a command line tool for Windows OS. So with using the, if your applications are hosted in a Windows environments, then you need to understand the PowerShell as well. Then the Python. So Python is basically, it's agnostic across the environment. That is, you can run it in the Linux, you can run it in the Windows as well. So um, and it is highly scalable. So I would recommend you to learn the Python as much as possible. And if you are really passionate about Python, you can run it in Linux, you can run it in PowerShell, and achieve your automations with using the script that is needed in the DevOps. The next one is IAC. So IAC is basically, it's a new technology or new way of handling the infrastructure. Earlier we used to spin up the infrastructure with using manual approaches, or by following the lot of run books, complex steps, right? So now that has gone day. What you do is, you're going to write your infrastructure in the code with using the tools and technologies that is available in the market. The first one is Terraform. Terraform is, basically it uses the HashiCorp language. HashiCorp is a company which is actually gives you these libraries, right? And the providers are like AWS, Kubernetes, Azure, like that, right? So Terraform is the tool that you can use it for infrastructure as a code. In the sense, you define your infrastructure in the form of a code in a declarative language. So it is not like a Python or PowerShell or shell scripting. It is basically, it has its own syntax that you have to follow and declare your own infrastructure. Then comes the JSON. JSON is like a kind of a helping tool that you can use it in the Terraform, or you can use it in the automations, which will speed up your automations for infrastructure provisioning or even automations around the infrastructures. Then comes the YAML. YAML is again, it is again as a declarative language, and that is used in some clouds. So for example, if you are using AWS, you might be well known about the AWS cloud formation, which is written in YAML, right? So, and that's the reason YAML is needed. Again, when you work with the CI/CD, that is, all CI/CD pipelines are defined in the YAML only. So understanding the YAML is very, very important. The next one is Cloud SDK. So as I said, when you work in the cloud like AWS, Azure, and GCP or other clouds, so every cloud has their own SDK. SDK stands for Software Development Kits. So you need to understand and have a deeper knowledge about cloud provided software development kits like Boto 3, Azure SDKs, right? So that you actually can use that, libraries, and try to build efficient automations that is needed for DevOps. As I said, automation is blood of DevOps. That's what I was talking about, right? Next is the backend. So backend is, there are scenarios when you are dealing with a very vast, the environment. In that case, you might need to build the integrations or backend. In that case, are basically called as a library or your own services with using the tools and technologies like Python. So I recommend you to learn Python for automations. And of course, it can be done with using the Java, Java as well, or even Go. Right now, the Go is also booming. So learning Go is also being recommended as per this video as well. Now let's go. So we have seen a lot of things. Now let's try to dig down. So what is that? The organization going to get the benefit out of it? Why the organization is telling you to, hey, this is the DevOps work that you have to do. Now let's try to understand what is the benefits. So as you see here, so there are a lot of benefits that the organization will realize with the DevOps methodology of working, right? One is, the as I said, that is the faster development, deployment, or faster delivery. Basically, it improves the better collaborations between the team who is actually working for a single cause. And then it actually improves the scalability, in the sense the lot of scalability problems were occurred before DevOps methodology. Now with the DevOps methodology, it has improved the scalability and then reduce the downtime, of course, because it is compact and integrated way of working. That's the reason it obviously reduces the downtime of the applications as well. Now if you see in the right hand side, that is a basically executive summary of benefits of DevOps. One is, of course, you're going to have a lot of cost savings here because of the manual works are being converted into automations. A lot of things are spinned up with using the code. A lot of human errors are being brought down. So what are all those? Basically, those are all cost savings. And your applications are being built at a high speed. What is that? That is basically faster to the market. High quality sector, in the sense that here you are giving the software engineer or developer more time to focus on the business applications, and that is where high quality software gets delivered. Then the improved collaborations, in the sense, now the principle of the DevOps says that integrate these two teams to deliver the single business cause. And that is basically improved the collaborations between the teams. And of course, enhances the scalability and the resilience of the business is being realized in the DevOps. Now let's go to the next topic, that is how DevOps is used in the real life. You might be wondering, can I get an example of what is the real use cases of the DevOps? Let's consider that, hey, you are working on e-commerce, the company. I'm sure that that company has a lot of e-commerce workloads, and that is like an example is, consider that you are working on an e-commerce site deploying a new feature. Say that you have the Amazon e-commerce applications, and in that applications you need to bring in some XYZ feature. Now again, you gonna to deliver that particular feature, try to understand that infinity symbol, and now you try to think a little bit about that infinity symbol, that is plan, code, build, deploy, test, right? And then monitor, then give it a feedback like that. So that is where the real use case of DevOps is all about. And then another one is streaming platform for, so one side, so DevOps practice not only for a single application delivery, it can be used at one more level above, that is at a enterprise teams. What are all the enterprise teams? Enterprise teams are the team who is actually delivering the platform in the modern world of IT, say cloud platform, or the Kubernetes cluster platform, or any other data analytics platform, right? That is where again you can use the DevOps methodology for real life use cases. That's where streaming platform scaling during high demand. So that is where you're gonna use the DevOps methodology here in the real life use cases. Now why does DevOps matters altogether, right? Let's try to see at a high level and try to look at only top level benefits of the DevOps. One, here we saw that the chaotics of the earlier, that is multiple teams, are generally two teams at a high level, development team and operations team, working in their own console and caring about their own deliveries, but they are not caring about a single they aim for both the team, right? That is to collaboratively deliver the business value. So that was actually slowing down in the earlier way of working. Now with the DevOps methodology, you have a improved the quality, basically that actually brought in the increased the collaborations, improved, that is actually lead to improved quality, reduce the effort, something like that. Yeah. So here is that DevOps is a cultural shift that actually accelerates the innovations and fosters the collaborations. It is not just about the tools, but about delivering the value to the customers in a faster and better way.